Hey everyone, today we will be talking about mass spectrometry. So mass spec is a tool, another tool that organic chemists use to find out the mass of a structure. So IR was a tool that found out the functional group. Now this is another tool that finds out the mass. So you'll notice that eventually there's going to be a time where we can figure, we got the functional group, we got the mass, and now NMR later, the next video we're going to talk about, which is going to be how to connect the molecule. And then that's it. These three tools can help us throughout the way. So about mass spec, there's some things that we have to understand. So one thing, we'll go through, I'll show you a diagram at the end. One of them is called a base peak. A base peak is the largest peak. And larger, what is largest? What does it mean? What that means is that's the cation, because mass specs only detects positive charges. So cation is the most stable. That's why it's absorbed the most. That's why it's the largest. So the most stable. And you can tell which one is more stable, which is stable or not stable, by looking at if it's tertiary carbocation, secondary, or primary, if it's alkanes. Okay. Again, don't worry. Everything will make sense near the end when we do the example. So that's a base peak. Another one is called a parent peak. Parent peak is a peak that is on the most right. That is actually your mass of your whole structure. So it's the peak that's on the right, that's the mass of the whole thing, the whole molecule. And you call that by M. So base peak, largest peak, parent peak, the most right peak. There are sometimes there's M+1 or M+2 peaks, and these are called isotope peaks. Isotope peaks because they're different isotopes, like M+1 or M+2, because things can be found in different isotopes. They could be, for let's say bromine is going to be 79 or 81. Chlorine could be 35 or 37. So depending on those and their ratios, that can tell us that what kind of isotopes do we have. So some examples. Well, let's share some examples. So let's say Br, bromine. Bromine has a 1-to-1 ratio. 1-to-1 ratio from is M+2, which is a little bit higher than this is M+. So you'll see, like near the end, you'll see two peaks, which are almost identical, because bromine is found approximately 50-50, like 45-55 or 55-45. That you don't have to know that much, but know it's almost around 1-to-1 peak. Chlorine, on the other hand, has a 1-to-3 peak, and its M+2 is a third as large as its M+ peak. Okay? So M+2 as third as large as M+. For I, on the other hand, I is like, you can tell there's a very large gap in your when you look at your mass spec, there's a large gap. And that gap is 127 units or mass apart. So why 127? Because the mass of I itself is 127. Another one is nitrogen. Nitrogen is, you can tell if there's nitrogen in your molecule or not if it's an odd number that you see. So let's say an odd mass. Because it's 15, so you know that's going to be an odd mass. But what if there's two nitrogens? Then it's an even. So if there's two nitrogens, then it's even. So there are going to be other hints that tells you there's a nitrogen or not, but there's not a nitrogen. So these are some basic ideas of some basic peaks that we have to know. Another tool to know, like some numbers to like it's simple math, you can add them up. But there's key things to remember is that, let's say if there's a peak right here, a peak here, the difference between the two is actually some fragment has been lost. So let's say if it's a CH3, that has a mass of 15. So if there's a 15, recall it, fragment being lost, or 15 mass that you can think of it's a methyl. If it's CH2, CH3, and it has to be cations, like I said, it's going to be 29. And you can keep on adding it up for propyl and so far and so forth. An important one that the professor at my university, when I took the course, and my students when they're taking the course, she likes to test something called an allylic. And allylics are at 41. Don't get confused because people think, oh, CH2, CH2, and CH3, which is a propyl, which is 43, oh, it's close enough, we can add it. No. 41, it's not propyl, it's allylic. Okay? Another important one, which professors like to put it on the test somehow, is benzylic, which is at 91. This is an important one because that tells you actually it tells you something very important. It tells you that there is a very stable peak after 91 because it can form a lot of resonance structures. We know from previous classes that more resonance structure something has, the more stable it is, the largest base peak it'll have. Okay, so that's some things that I would like you guys to understand. Okay, so this is your typical mass spec spectrum. It won't be as badly drawn, but this is what it will look like. So the first things first, we look at your highest peak, which is, what's it called? Base peak, good. So which is right here. Now, if you have your base peak here, which is at 91, what was significant about 91? Why is 91? Why would it be the largest peak? What was there? Think about it. Okay, so if you thought about it, you're right. It should be a very stable structure because it's so large, and you have benzylic, which is nicely stabilized by resonance. Next thing we'll look at is your parent peak. Now you have two 1-to-1 ratios of, you had an M peak and M plus 2 peak. So what do you guys think is, the 1-to-1 ratio with 1 M and M plus 2 peak approximately being equal? Think about that one. So if you guys guess BR, you're right. So now BR is a classic example of why BR is because there's 1-to-1 ratios and there's M and M plus 2 peaks, which is just 2 apart and they're exactly identical. So we got a BR and you got a benzylic. Now, the one simple trick that I'll like to share with my students and I'll share with you guys is that you just try to add the numbers. We got 91 and one form of, let's say 79 for BR. It could be 81 if you want to use the other isotope. It's perfectly fine. So we can do both ways. So if you add them up, you get 0, 1, that's 170 here, or 2, 172 here. So you take 170 and subtract it from your original mass, which is 184. So you do 184 minus 170, or you do 186 minus 172. Both cases you'll see you will get 14. Okay? So we know that we're almost done. We got a benzylic and BR. So if you had to guess without any information, it'll just be something like that. And that's the structure. Alright guys, hope that was helpful. Thank you very much. Please rate, comment, subscribe, and have a nice day.